Hello everybody. Class 11th, I am going to post another video for you on one more important chapter. सोचो कौन सा है? कुछ तो लिखे हैं. यूनिफॉर्म सर्कुलर मोशन. ये नहीं पढ़ा ना अभी तक? पढ़ लेते हैं इसको. Uniform circular motion. Now before I come to what is uniform circular motion, before I come to this particular topic, let me tell you, it's not a compulsion that motion has to be always uniform. Non-uniform भी तो हो सकता है. So what the child will do if the body is having a non-uniform circular motion? तो दोनों पढ़ लेते हैं ना, दोनों पढ़ लेते हैं. On one side, let us tackle with non-uniform circular motion, or let us know when the body will execute non-uniform circular motion, and on the other side, let us know when the body will execute uniform circular motion. See, the basic difference between the two is, by uniform बनाऊंगा तो body will be moving on a circle like this. And if I draw it as a non-uniform, so it will be moving along a curve, maybe somewhat like this. What is the difference? क्यों होता है ऐसा? The reason are two accelerations. If the body is executing non-uniform circular motion, then it is under the effect of two accelerations, tangential and radial, AR. And when the body executes only circular motion, it is under the effect of only radial acceleration. There is no tangential acceleration. That is the basic difference. That means in case of non-uniform circular motion, the tangential acceleration or AT is non-zero. And since it is non-zero, it increases the magnitude of velocity, or it increases or decreases the speed of the body. And AR, that we call it as radial acceleration, this is also non-zero, and this acceleration continuously changes the direction of motion of the body. The cumulative effect of these two is that the body is moving along a curved path. Remember, the two accelerations are always perpendicular to each other. Hence, the net acceleration possessed in case of non-uniform circular motion by the object is root AT square plus AR square. Root AT square plus AR square. When you talk about uniform circular motion, there is no tangential acceleration. AT is 0, but AR is non-zero, due to which the speed of the body, if you talk about the speed of the body, the magnitude of speed at all the points will remain constant, V. Direction keeps on changing as shown by the arrows. Say the body is moving in anti-clock direction, so the magnitude of speed does not change. Tangentially ही करता है ना, वो speed को सिर्फ change करता है और कुछ नहीं करता. तो इस case में there is no tangential, therefore no change of speed, and the body will move with a constant speed. I said constant speed. Velocity changes due to change in direction, and direction change is being brought about by this radial acceleration. So that is the basic difference between the uniform circular motion and the non-uniform circular motion. Now in this case, if you ask me, so what is the net acceleration? पूछना ही नहीं चाहिए, आपको पता है. It is AR. Let me tell you, this AR is also known by the other name, in this case centripetal acceleration, and the value of this acceleration is given as V square by R or omega square R. Now what is V? V is the speed, R is the radius of the circle in which the body is moving, omega is the angular speed. We will discuss it later on. So that is the basic difference between a body executing non-uniform circular motion and uniform circular motion. Conclude करते हैं. Non-uniform में path is curved, यूनिफॉर्म में पाथ है सर्कुलर. नॉन यूनिफॉर्म में टू एक्सेलरेशन साइमल्टेनियसली एक्ट, टेंजेंशियल एंड रेडियल. यूनिफॉर्म में देयर इज ओनली वन एक्सेलरेशन एक्टिंग, रेडियल. The net acceleration of the body in non-uniform is root 80 square plus AR square, while the net acceleration in case of uniform circular motion is simply radial acceleration, that is v square by r or omega square r. Right? So that these are the basic differences between the two categories of motion. अब पढ़ना क्या है? पढ़ना तो यूनिफॉर्म है. तो यूनिफॉर्म में बिफोर आई मूव अहेड, यहाँ पे बोला ना मैंने ओमेगा, angular speed. Speed, you know what is angular speed. See, when we talk about the motion of a body along a curved path or a circular path, so we take into account the two variables of an object, linear as well as angular. Consider this situation. I'm going to talk about the linear and angular variables. Let us assume a circle on which the body is, say, moving in anti-clock direction. O is the center of the circle, say, and at t equal to 0 body is at point P. Means object अपना motion P से start करता है. Object अपना motion P से start करता है. उसकी जहाँ से मर्जी है वहाँ से start करेगा. ठीक है. Now what happens in some time particle moves to Q. In some time particle moves to Q. बोले what time? Say time at Q becomes dt. Small time. In the process, the particle suffers a displacement, and the new displacement vector or position vector of the particle can be given as OQ. वो नहीं लेना है यहाँ पे. In both the cases, you see OP or OQ both are equal to the radius of the path of the particle. Correct? Now there are two options in front of us. We can measure the linear displacement that is from P to Q. We can measure the linear displacement that is from P to Q and label it as ds, small displacement. So what is ds? Linear देखिए पहले. What is ds? Linear displacement measured as ds. ठीक. So this is naturally measured along a line PQ from initial position to the final position. Divided by the time taken, you'll get the linear velocity. That is ds by dt. Labeled as v vector. पढ़ा ये भी हमने स्ट्रेट लाइन में. वेलोसिटी चेंज को डिवाइड करो किससे? टाइम से. सो एक्सेलरेशन वेक्टर will be obtained, that is dv by dt equals to the linear acceleration, that is a. So these are all linear variables. We have studied these if we were talking about, or when we were talking about, not if, when we were talking about the straight line motion. सर्कुलर मोशन में एक और ऑप्शन है हमारे पास. सी व्हेन द पार्टिकल गेट्स डिस्प्लेस्ड फ्रॉम पी टू क्यू, इट सफर्स अ डिस्प्लेसमेंट अलोंग द एंगल विच कैन बी रिटन एज डी थीटा, स्मॉल एंगुलर डिस्प्लेसमेंट. तो भाई साहब एंगुलर वेरिएबल्स पे आ जाते हैं ना. एंगुलर वेरिएबल्स में पहला डिस्प्लेसमेंट रिटन एज डी थीटा. ध्यान रहे मेजरमेंट इन रेडियंस, एसआई यूनिट ऑफ एंगल इज radian. Now this d theta or this small angular displacement takes place in time, dt minus 0, that is dt. So divide this angular displacement with the time taken to get the angular velocity, and that will come out as d theta by dt. बच्चे इसी को कहते हैं ओमेगा, इसी को कहते हैं ओमेगा. Now, if the angular velocity changes, if it remains constant, fine, there is no angular acceleration. But if the angular velocity changes with time, we can obtain angular acceleration. That will be given by change in angular velocity d omega upon time dt, denoted by alpha. So what are the linear variables? ds, v, a. Angular variables d theta, omega, alpha. If this is radian, omega will be radian per second, isn't it? And alpha will be radian per second square. Correct? अच्छा ओमेगा के और कोई फॉर्मूले जी यहाँ है ना. Omega can be written as d theta by dt or 2 pi f or even 2 pi n by 60. What is this? F is frequency of revolution. How many revolutions a particle executes per second? And what is n? n को कहते हैं बच्चे rpm. फ्रीक्वेंसी से मिलता जुलता है, बस पर मिनट मेजरमेंट करता है, तो रेवोल्यूशन पर मिनट. rpm means revolutions per minute. So if you are given revolutions per minute, use 2 pi n by 60 to find omega. If you are given frequency of revolutions बोले 20 per second, तो in place of f put 20, obtain the angular velocity or the angular speed. And if you are knowing the angle turned in a given time, then you can use d theta by dt, right? Now the question arises, is there any relationship between the linear and the angular variables? है जी हाँ है तो क्या है, चलो देखो. See, d theta is a very small angle, na? Because d theta is very small. Hence we can say arc PQ will be approximately equal to PQ, that is line PQ. लाइन लिख देता हूँ ना, तो बोलोगे इधर PQ इधर PQ, समझ ही नहीं आया. तो line PQ, the length of arc PQ will be approximately equal to line PQ. अच्छा, आर्क का फॉर्मूला क्या था, याद है? नहीं ना. रेडियस into angle subtended by the arc. Angle subtended by the arc, correct? Now what is line PQ? It is, you know, ds vector, linear displacement, equals to radius r, angle subtended d theta. तो ds equals to r d theta. Linear displacement क्या होता है? Radius into angular displacement. In the similar manner, दोनों sides को time से divide करो, or we can say ds by dt will be equal to r into d theta by dt, isn't it? Now ds by dt उधर लिखा है v, linear speed of velocity, equals to r d theta by dt, angular velocity. So v equals to r omega, इसको लिखने की जरूरत नहीं है, v equals to r omega. फिर टाइम से डिवाइड करो, तो dv by dt, differentiating both sides ना, radius constant, angular velocity changing, so d omega by dt. What you will get is linear acceleration is equal to r into alpha. So this is how the variables are related with each other. Actually reality ये है कि अगर आपको लीनियर वेरिएबल चाहिए तो थंब रूल्स याद कर लीजिए. थंब रूल्स नहीं होते हैं, थंब रूल होता है, एक ही होता है. लीनियर वेरिएबल इज ऑलवेज इक्वल टू रेडियस इनटू एंगुलर वेरिएबल. मतलब एंगुलर वेरिएबल को अगर आप रेडियस से मल्टीप्लाई कर दोगे तो क्या मिलेगा? लीनियर वेरिएबल मिल जाएगा. इसको याद करो ना एक लाइन में. बार बार क्यों याद करते हो? v इक्वल टू आर ओमेगा, इक्वल टू आर अल्फा, नहीं उतने क्यों याद करें? वैसे ही बहुत कुछ याद करने का टाइम नहीं है हमारे पास. कितना याद करेंगे? बहुत सारा कुछ है. तो बेटर इज वी रिमेंबर दिस. सो जस्ट टू कंक्लूड, इस सेक्शन में we have two categories of variables along which measurement can be done in a circular motion. That is, along a line known as linear, or along an arc, known as angular. The respective variables are displacement, velocity, acceleration. Angular respective variables are angular displacement, angular velocity, angular acceleration. How they are correlated with each other? Any linear variable is equal to the product of radius and the corresponding angular variable. Remember, angular speed can be further written by two more formulae. They are 2 pi f and 2 pi n by 60, where f is the number of revolutions executed by the particle in 1 second, known as frequency or linear frequency, and n is rpm, known as revolutions per minute, or the number of revolutions that a particle executes in 1 minute, right? So that's all with linear and angular variables. Moving on to another topic, जो फर्स्ट स्लाइड में था, क्या था? सेंट्रीपिटल एक्सेलरेशन की वैल्यू इज v स्क्वायर बाय r. कैसे प्रूव करता है? So let us try to prove that centripetal acceleration is equal to v square by r. करूं? करते हैं. I'll do it for you and then I'll explain what I've done. Na? I'll do it for you and then I'll explain what I've done. Right class, here is the proof that I've done. Now, क्या किया ये सब? See, with the blue I've shown you, with the blue marker I've shown you a particle or a circle on which a particle is moving in the anti-clock direction, right? Initially, my particle is located at P. Consider this diagram, diagram 1. My particle is located at P. The time measurement we have started from P, therefore at P time equals to 0. After a while, that is in small time delta t, particle gets displaced by small displacement delta s and moves to a new position q. तो जब particle q पे पहुंचता है, समय हो गया delta t elapsed and displacement has been as delta s. Accordingly, correspondingly, the angular displacement we have taken as theta. Also, the radius of path has been assumed as small r, which will remain same, that is OP and OQ, they will be equal. At P and Q, I have drawn the velocity vectors of the particle respectively v1 and v2. But as we all know, only direction changes in case of uniform circular motion. The speed does not, मतलब magnitude नहीं बदलता. So the magnitude or modulus of v1 and v2, they will be same as v. Let the speed be v. So what v denotes? V denotes here as speed. इसके बाद class on the same triangle that is corresponding to triangle OPQ, I have drawn triangle OAB, but this time OAB is corresponding velocity triangle. As you can see, OA represents V1 and if OB represents V2, delta V or change in the velocity vector will be represented by vector AB, right? Now, since these two triangles are similar, therefore, we'll take the proportion of the respective sides, theta के सामने PQ in the first triangle and theta के सामने AB in the second triangle. So PQ upon AB is equal to any other side, say OP, that is R later on, and other side OA, right? आप OB भी ले सकते हैं corresponding और OQ भी ले सकते हैं. That things will remain the same. Now the value of PQ is, delta S, length. Arrow हटाना है, length लिखना है. तो length क्या है? Delta S. AB, the length of the side AB is delta V, as you all know. What is OP? OP is radius R. And what is the value of OA? It is, दिख रहा है velocity vector V1, but the value, scalar value is V. So we have written it as V. Now we convert this expression for delta V. So delta V is obtained as delta S V by R. Now dividing both sides by the time elapsed, that is delta T, I'll get delta V by delta T equals to delta S by delta T into V by R. The change in velocity upon time is acceleration A, displacement upon time is speed. So V into V becomes V square by R. So the expression for the centripetal acceleration is obtained as V square by R. Or corresponding expression can be, you put, because we have already discussed V equal to R omega, so in place of V you can put omega square, in place of V square you can put omega square R square. One R will get cancelled, you'll get it as omega square R. Therefore the value of centripetal acceleration can be obtained as V square by R or omega square R, right? The corresponding to this centripetal acceleration, naturally you'll be having the force that is known as F centripetal force. और इस centripetal force का value क्या होगा? ma से निकाल लो, it will be mv square by r. So the value of this centripetal force F will be given as mv square by r or simply m omega square r, right? So this is how the expressions for centripetal force and centripetal acceleration are obtained. Both the force as well as the acceleration, they are acting towards the center of the circle along the radius. ये हम डिस्कस कर चुके हैं पहले भी. Corresponding to centripetal force, there is a centrifugal force also which comes into action due to inertia of direction of the particle. The nature, that is the magnitude and the direction of that centrifugal force we have already discussed in laws of motion. Those who have not seen that video, they may, right? So centripetal force, centrifugal force, centripetal acceleration, centrifugal acceleration. We have all discussed these in magnitude and direction. That's all in this video. In the next video, I'll be discussing with the applications of the centripetal force and acceleration in horizontal and vertical circles. So that is for the next video. Thank you.